So welcome everybody to this latest A2 video on 162 Maths, and in this video we're continuing with binomial expansion. However, this time we'll be focusing on when you haven't got 1 plus x in the bracket, and also when n is a fraction or a negative. Now, sometimes the function inside a bracket doesn't begin with the term of positive ones. Now, for this, what you need to do is, for you to use the binomial expansion formula, this must be the case. So if a function does not start with positive 1, then what we need to do is factorize the expression before attempting to expand it using the formula. So what we mean by this is, basically, if we end up with this sort of scenario where we've got anything that's not 1 plus something x to the power of n, then what we need to do is factorize it with respect to a. Now let's just go through a few examples of what we'd have to do. So if I had 2 plus x to the power of 3, let's say. Now the power is insignificant to this. So what we need to do is we need to factorize this with respect to 2. Now unfortunately we can't just simply take the 2 out, like so, and make it like this, because if you think about indices, and so what I mean by that, we can't just simply take the 2 out and have it so it looks like that. Because one, obviously, the x has been taken out, so we need to do something with that in terms of taking that by 2. But also using BIDMAS is that we do the power first before we do the multiplication. So what we actually need to do is, if we are to take the 2 out, we need to take 2 to the power of whatever the power is, and then we can then change that to a 1, and then obviously we need to divide the x by the factor that we've taken out, which is 2, and that will be like so. And now what I can then do is then turn this into 2 cubed, or 8, and then I've got my expansion of 1 plus a half x to the power of 3, and this is what I then use the formula on this bit. So again, if I had something a bit more complicated, so let's say I had 4 minus 3x to the power of minus 2. Well, again, the minus 2 makes absolutely no significance. I'm just going to do this over here. So what I need to do is I need to take out the 4 to the minus 2 out. I then incorporate my square brackets, and then I've got 1 minus 3 over 4x to the power of minus 2. And this is what I then use the quadratic formula on. Now, one thing I would suggest is that this is the bit that a lot of students tend to forget, is they take the 4 out, which is great, but they don't take the power with it. And it's always important that you do remember to take that power forward. And also another key thing is when you're looking at your expansion, when this has been expanded, make sure you then multiply everything by whatever this is. And again, when we go through some examples, I will obviously highlight this particular feature. So let's have a look at this first example. It says, so the question says, obtain the first 4 terms of the expansion of 1 over 3 minus x, given the range of values of x for which the expansion is valid. So again, the first thing we want to do is, let's start by writing that we are going on to work out the solution. First thing we want to do is convert it using indices. So I've got 1 over 3 minus x, which then becomes 3 minus x to the power of minus 1. Now from this, what we then need to do is go on to factorize this. So factorizing this then becomes taking the 3 to the power of minus 1 out. I then end up with 1 minus, and it's going to be a third x. I don't know why I'm putting these brackets in, so let's just leave that, x over minus 1. Now if I wanted to, I could easily write this as 3, or 1 over 3, if I wanted to simplify that as 1 minus x over 3 to the power of minus 1. Those two lines here and here are both exactly the same, so it's entirely up to you how you then want to go on and write it. Now in terms of working out the solution for this, I'm going to keep that as a third, and what I'm going to do is I'm going to use the binomial expansion to do this yellow part here. So this, well, let's not use yellow, let's go for green, so I'm going to expand this bit here. So from this, what I end up is with 1 plus, now from this, what do I end up with? Well, I end up with n equals minus 1 and x equals x over 3. So they're the substitutions I'm going to be using. So I've got 1, and then I'm going to end up with minus 1, and then it's minus, oh, I forgot the minus there. It's going to be minus x over 3 plus minus 1 minus 2 over 2 factorial, and that's minus x over 3 squared, plus, and then I've got minus 1 minus 2 minus 3 over 3 factorial, and I've got minus x over 3 cubed. Now from this, what I then need to do is go on to simplify. Now you do need to be careful with this. Try and do it in sections and just be careful of the signs and be careful of how the signs work on your calculator as well. Whenever you're using negatives on your calculator, always make sure that you are correct using brackets, and sometimes you might find it easier to not even use a calculator at this particular stage. So what I've got is I've got a third, and again I'm not going to multiply out the third just yet. I'm just going to simplify what these brackets are, which I end up with 1 plus a third x plus a ninth x squared plus 1 over 27x cubed. So now all I need to do is expand the third out. So just going to multiply the third by each of those 4 terms to get my final answer, which is that 1 over 3 minus x is approximately, and the answer is going to be a third plus a ninth x plus 1 over 27 x squared plus 1 over 81 x cubed. Now also just make sure that your x is not in the denominator, and so that there would be my expansion. Now going on from the next part of the question, it talks about validity, so it's valid for, and again going back to the original, I've got 3 minus x to the power of minus 1. So what does that become? Well, if I set my modulus up, I've got minus x, which is equivalent because it's a modulus, it's less than 1. So then all I've then got is that x is less than 3. So basically what this then becomes is that this expansion is valid where x is between minus 3 and positive 3. And again, either of your answers as this or this would get you full marks, but if you're coming to the end of your A2 syllabus, then I would go for writing it using the mods. So looking at our second example, so it says find the quadratic approximation for 2 plus 3x to the power of minus 2, giving your answer in the form of a plus bx plus cx squared, and state the range of values of x for which the expansion is valid for. So for this, we just need to highlight the key words. So we're looking at quadratic, and we want our final answer to look like this. Now looking at this stage here, all it's basically saying is for me to go up to x squared. So sometimes it'll be explicit in the question, sometimes they may use particular words to sort of, that's what they're actually meaning. So let's go straight on to the solution. So we don't need to worry about converting into indices because that's what we've already got. So we've got 2 plus 3x to the power of minus 2. Now from this, what we need to do is try and get this to plus 1. So let's factorize it first. So I've got 2 to the power of minus 2, and then I've got 1 plus 3 over 2 x, and that's the power of minus 2. So then simplifying this, I could then convert this into a quarter. That's not a problem, but then the first thing I'm going to do is expand this. So from this, what we've got is we've got a quarter, which I'm going to leave on the side, and then working with the expansion, well, let's first start off by writing what my variables are. So here I've got n equals 1 and x equals 3 over 2x. So from this, what we've then got is I've then got 1 plus, and it's going to be minus 2. Sorry, the power should be minus 2. Make that a little bit neater. So minus 2, so I've got minus 2, and then I've got positive 3 over 2x plus minus 2 minus 3 over 3 factorial, and then I've got 3 over 2x squared. Now I don't need to go any further because I want just the highest coefficient of x squared. I want, well, the highest degree of x I want is x squared. So I can stop there. And again, how I go about doing this is I'll do this bit on the calculator, and I would do the fraction bit, the x part, usually using my head. Or if I was really struggling, I would use a calculator separately for that. So I've got a quarter, and then expand this out, I'm going to end up with 1 minus 3x plus, and it's going to be 6 over 2 times 9x squared over 4, which then gives me a quarter, and then 1 minus 3x plus 54. What's going on with that plus? Let's just sort that out. Plus 54 over 8x squared, and then if we then expand everything out, so I've got a quarter minus 3x over 4 plus, and then we've got 54 over 32, which simplifies to give me 27 over 16x squared. And there is my final answer. Now in terms of for the validity, let me just do this on the same screen. So it's valid for, and working with this, what we've got, now remember we're looking at the original equation, so here we've got 3x over 2, and what I then want to do is make this make x a subject. So I've got the mod of 3x is equal to 2, and then the mod of x is less or equal to 2/3. So what is then, it's then valid for that range, or I could write it as minus 2/3 x and 2/3, and there is my final answer.